Welcome back to our lesson video 10 of programming with C++. At the end of this video, we will understand what operator overloading is and how to use it. We also learn about derived classes and how they work. We also master the concept of inheritance and its different types, understand polymorphism and how it makes your code more flexible. So without wasting my time, let's dive into it. Let me see operator overloading. What exactly does it mean? No, it's a really good feature that allows us to define operators, work with our custom classes. It's like when you write maybe 5 plus 4, the computer knows exactly what to do. It adds 2 numbers and gives you the value 9. What about if you have 2 objects of a class you created? What should that class operator do then? The operator overloading lets you define exactly what happens when you use the operators like class, minus, multiplication, and equal to, and many others with custom objects. For example, if you have a point class representing coordinates, you might want point 1 plus point 2 to add their x and y coordinate together. Or if you have a string class, you might want the plus sign to concatenate two strings. So this is the operator we commonly use for operator overloading in C++. There's the arithmetic operation, the plus, minus, multiplication, division in the module. There's the ampersand for the pointer location, and this for logical operations. And the relational operations, this for the equal to, this also for not equal to, this one for greater than or equal to, and less than or equal to. And this one the pointer operation, the ampersand and the asterisk. So let's break down this operator overloading syntax. So we have return type. Is what type of value the operator returns. That's the operator. This is the special keyword that tells C++ we are overloading an operator. And the symbol that actually the actual operator we want to overload, like the plus, minus, or increment or anything. We also have the parameters. The parameter is our overloaded operator we'll work with. And there are some rules for operator overloading. Operators you cannot overload. The conditional operator, which is the question mark, this operator, you cannot overload them. We have the scope resolution operator and the dot operator, the pointer to remember operator, and the typed operator, the size of operator, and the align of operator. You can only overload existing operators. You can't create new ones. You can't change what the operator does with built-in types. At least one operand must be a user-defined type, like your class. You can't change the number of operands an operator takes. The precedence and associativity of operators remain the same. The advantages of operator overloading. Why would you want to overload operators? Here are some main benefits. They simplify the syntax. The code becomes more readable and intuitive. Instead of writing pointer one dot add pointer two, we can write pointer one plus pointer two. Then going that. And you also want consistency in our programming. Your custom classes can have like built-in types, making them easier to use. So for easier understanding, using familiar operators like the plus and the minus makes your code more intuitive for other programmers. And the disadvantages of operator overloading. The potential misuse if you overload operators in unexpected ways, it can confuse the programmers. Complexity. By using operator overloading can make your code harder to understand. A limited overloading. Not all operators can be overloaded, as we saw earlier. Let's talk about derived classes. This is where things get really interesting. A derived class is a class that's created from an existing class. Think of it as if you have a general vehicle class, you might create more specific classes like car, motorcycle, or a truck from it. The original class is called the base class or the parent class. The new class created from it is called the derived class or the child class. The derived class inherits all the members and functions from the base class, but it can also add its own unique features. And the syntax for writing the derived class definition. You have your class, your derived class name, access specifier, and your base class. So let's talk about derived class using access modifiers. When creating derived classes, you can control how the base class members are inherited using access modifiers. For beginners, I recommend using public inheritance for most of the time, as it is the most intuitive and commonly used. So, so for the public, if a derived class is declared in public access, the members of the base class are inherited by the derived class just as they are. For the private too, if a derived class is declared in private access, then all the members of the base class become private members to the derived classes. But for the protected, the public members of the base class becomes protected members in the derived class, and the private members of the base class are always private in a derived class. Let's talk about inheritance. Big look into the inheritance. Inheritance is one of the core principles of object-oriented programming. It allows us to create new classes based on existing ones and in promoting code reuse and in creating logical relations between classes. Let's take inheritance like a family tree. The child inherits traits from their parents, but they can also have their own unique characteristics. So we have types of inheritance. You have the single inheritance and a hierarchical inheritance. For the single inheritance, we have multiple inheritance and multi-level inheritance. For the multiple inheritance, a derived class inherits from multiple classes. So for the multiple inheritance, let's say this is the father and this is the mother. The child is inheriting from both the father and the mother. That's the uh, multiple inheritance. We also have the multi-level inheritance. This is the grandparents and the grandfather. The father is inheriting from the grandfather, and the child too is also inheriting from the father. That's a multi-level inheritance. And we also have the hierarchical inheritance, which multiple derived classes inherit from the same base class. For this is the father, and this is the first child, second child. The first child is inheriting from the father, and the second child also inheriting from the father. That's a hierarchical inheritance. So we also have hybrid inheritance. This combines multiple types of inheritance. So we can see this one. Can see this one is the hierarchical inheritance. This is the father, this is the first child, the second child, they are all inheriting from this one. And this one too is the multiple, this one too is the multiple inheritance. This is the father, this is the mother. The son is inheriting from both the father and the mother. You have the rules for inheritance. The first one is the static members are class dependent and are not inheritable in traditional senses. And the two, friend classes are not inheritable. Friendship is not inherited. And constructors and distractors are not inheritable. Each class needs its own. Now let's talk about polymorphism. This is Polymorphism means many forms. It's the ability of different classes to be treated as instances of the same base class, while each class can never have its own access, its own specific implementation of the same method. Think of it like this. If you have different types of animals, they all can make sound, but each animal makes a different unique sound. A dog can bark, a cow, a, a cat can meow, and a cow moves. The action is the same, making a sound, but the implementation is different for each animal because they have their own unique sounds. And this the sample code for writing inheritance. You need your class and your class name is my record, your public int my age. Before get age. Ages. So you can try your hands on this code to get more understanding.